Okay, in section 5.2, we're going to get into really what we consider trigonometry. So when we get into trigonometry, the first thing that we start seeing is what are called trig functions. The long way of saying it is called trigonometric functions, but we usually just shorten it to trig for trig functions. And there's 6 main trig functions. However, there's really only 3 main trig functions. The other 3 are just kind of slight alterations on the other 3. So the 3 main trig functions that we'll see are sine, sine, cosine, and tangent. Those are your 3 main trig functions. There are 3 other trig functions, which are cotangent, secant, and cosecant, but those are just going to be reciprocals of the other functions. So we're not going to see those as really, they will have different graphs, they will be a little bit different, but they're not distinct new trig functions. They're based off the ones we already have. When we start talking about trig functions, we start using these 6 trig functions with always a right triangle. And it'll look something like this, where we have a right triangle that comes off of the x-axis here. It starts on the x-axis. Remember, our angles are usually positive, and so they start by going counterclockwise. We're just going to leave this one in quadrant 1, and then they shoot out, and we've got our angle, and we'll call the angle here, it looks like a 0 with a line through it. That is called the Greek letter theta. So we're going to use a lot of Greek letters in this class. And we're usually going to have a point that creates our angle. Well, if we have a point, that means we're going to have an x and a y. Remember, x is how far out to the left or right that we're going, and y is going to be how far up or down we're going. But we're also going to start talking about a radius, which is how far out our angle is actually going to go when we use our point. And we're going to start talking about circles too. That's why we mentioned the word radius. But notice we do have a right triangle. So we have what are considered to be, besides angles, we have what are considered 2 legs. And remember the other fancy term for the other side? We are using it as a radius, but it's also called the hypotenuse. Then we also want to be able to talk about, if we're coming out of this angle here in the center, is we also want to be able to talk about sides and how they're related to that angle. So, for example, if we're looking at this angle theta, the side across from it is called its opposite. The side that's right next to the angle is called the side that's adjacent. And the side that is always opposite the 90-degree angle, what's always opposite the 90-degree angle is the hypotenuse. So we're going to be starting to throw around these terms of adjacent, opposite, and hypotenuse. Now, hypotenuse is always going to be that side opposite the 90-degree angle. Which sides are adjacent or opposite are always going to depend on which angle you're actually looking at. Opposite is always the angle on the opposite or across from side of the angle you're using. And adjacent, I always think as means next to. The side that's next to your angle that's not the hypotenuse. So, we have 3 main sides, adjacent, opposite, and hypotenuse. And we've got 3 main trig functions, sine, cosine, and tangent. And then we've got 3 secondary trigonometric functions, which is cotangent, secant, and cosecant. So before we get into anything, what we want to do is focus on our 3 main trig functions. The first one being sine. And the way that we're going to remember what sine is we're going to use Sohcahtoa. And so is going to be telling us that sine, and we're going to use SIN as a shorthand for sine, is going to stand for opposite over hypotenuse. That's why the O and the H in so Sohcahtoa. The next part we're going to look at is we're going to look at cosine. And that's going to be our Ca. The C, the cosine, we'll use cos as a short for cosine, is going to be the Ca. The A is for adjacent, and the H is for hypotenuse. So the cosine will be adjacent over hypotenuse. And the last one, tangent, will be the Toa, which is going to be telling us that tangent, and we'll use shorthand TAN for tangent, is going to be opposite first. So opposite over adjacent. And again, your sine, cosine, and tangent is going to change based on which angle you're coming from. Your hypotenuse should always be the same, but whatever's your opposite or your adjacent side is going to be changing based on which angle you're coming from in your right triangle. So, key thing to remember is your Sohcahtoa. Yes, I would make sure that you can remember this. It's a great mnemonic that will help you remember which parts of your triangle gets used for which of the trig functions. And this is going to get used over and over and over throughout the entire course. Now, the reason why we really didn't mention the other three trig functions yet is because if you can remember the sine, cosine, and tangent using the Sohcahtoa, cotangent, secant, and cosecant, not so bad because they're just going to be reciprocals of the three trig functions we already have. What does reciprocal mean? Remember, reciprocal means flip it upside down. So we just have to know which one is the reciprocal of which one. So for sine, we had opposite over hypotenuse. Its one that it's going to match up is cosecant. Those two are going to be reciprocals of one another. And again, this is sine and cosecant. And instead of writing out cosecant every time, they shorten it to CSC, but these two are reciprocals of one another. What does that mean? It means that if sine, just as an example, is, let's say, 3/5, cosecant would be its reciprocal, flipped upside down, 5/3. Okay. We also have cosine here, which is adjacent over hypotenuse, the Ca in Sohcahtoa. And its reciprocal it's going to match up with is secant. So that's another thing we have to remember. And again, what that means is those two will be reciprocals of one another. So what that means is if cosine is, let's say, 4/5, that means secant would be the reverse, 5/4. It'd be the reciprocal. Okay, so how do I keep which one goes with which separately? Because we've got cosine that now goes with its reciprocal is going to be secant, and sine that goes with cosecant. I always remember that the two cos can't go together. So cosine can't go with cosecant. It has to go with just regular secant. Sine then has to go with cosecant. So the two cos, cosine and cosecant, do not go together. So the sine and the cosecant go together, and cosine and secant go together. And then what's nice is with tangent and cotangent, those are reciprocals of one another as well. So, for instance, if tangent here was, let's say, 3/4, cotangent would be its reciprocal 4/3. And what they've done is they've shortened cotangent to the first three letters, cot, tangent to TAN. We've also shortened sine to to sin, and cosecant to CSC. And we also have cosine, which has been shortened to cos, and secant, which has been shortened to sec. So the only one that seems kind of odd is the cosecant was shortened to CSC, but that'll be something that you just adapt to. It's not a big deal. So now we know which ones are reciprocals of one another. That's what this lower part is saying, is just that cotangent is the reciprocal of tangent, secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Yes, you do need to have all this memorized because you will not be allowed to create a formula sheet to use on a test, so you need to know this. And it will be used on every single test. So again, just writing it out in words, we kind of link which ones are reciprocals. So now the question becomes, how does this really affect anything and how does it come into play when we actually do an example? So let's take a look at problem A.